Good evening, everyone. Welcome to Salt City Data Community. Thank you, everyone, for joining us. We're going to get started here. Welcome to tonight's presentation. We are joined by Steve Wallace today, who is a professor at Syracuse University in the iSchool, and is an expert on data in healthcare. So he'll be speaking about his experience and giving us some visualizations and giving us some examples of the ways that data are used in healthcare. Quick introductions are actually first, as Ashley mentioned in the chat, this session will be recorded. Recordings are available on our YouTube, and any supplemental material will be available on our GitHub. My name is Amanda D'Arcangelo. I'm one of the co-founders of Salt City Data Community. We're a small group of individuals who really get excited over data, and we're happy that you could join us. I have been in data for almost a decade now. I really love it. I started the group because I like being able to hear people speak that I want to hear speak about data, and I get to pick people myself, which is really fun. I will hand it over to Ashley.
Everyone. Like Amanda mentioned, I'm also one of the co-organizers of Salt City Data Community. I'm a data analyst in Syracuse, and I'm super excited to learn from Steve tonight about more data in healthcare. So I'll hand it off.
Yeah, so without further ado, here is Steve Wallace. Take it over.
Okay, well, thank you very much. Hello, everybody. As Amanda mentioned, I'm Steve Wallace. I'm currently a professor of practice in the School of Information Studies up at Syracuse University. Before that, I had, and I still have, a small consulting business. Most of that has been working in healthcare, working for large hospital groups, primarily out of Rochester, where I used to live. But most of my career, I really was I spent as inside kind of corporate IT worlds as a chief information officer for a number of organizations. So I've kind of seen a lot of different industries and a lot of different technologies come and go. I didn't have any experience going into healthcare before I started consulting, but I spent about 5 or 6 years there, and it was really pretty interesting endeavor. It's in many ways, it's very similar to other businesses in some parts, but in many ways, it's very different. And I think one of the things that makes it very different is the data and the data structures and the computer systems and the kind of the language that people in the healthcare industry use. So what I'm hoping to do today is to share just some information about that. Really, we'll talk about 3 things tonight. First is kind of the healthcare data and a data warehouse design. There's some pretty well accepted industry standards around how healthcare data is organized. So we'll review that and talk a little bit about interoperability and how that all works. The second thing is I teach applied data science classes, and so I'll show you some like a data science pipeline where we'll source some data from 2 different healthcare data-oriented files. We'll merge it together, we'll build a machine learning model, and then we'll see the output of that, how we can basically risk score some patients. And then the third thing we'll do is we'll take a look at some visualizations that I've got. I didn't develop them, I found them. They're part of the Tableau ecosystem, which is a pretty rich visualization tool. So that's kind of our agenda for tonight. Any questions before I get started? Great, and I'm hoping I can move through the slides relatively quickly so we've got some time for questions afterwards. So let me just kind of share my screen here. Let me go over to here, and I apologize, these are SU slides. I'm not really trying to get a plug for SU or anything, it's just a slide deck that I had from before. So I can't really see you guys. Can everybody see the screen okay?
Looks great.
All right, great.
Yep.
Great. So as I mentioned, the one thing I didn't mention, I think, in terms of tonight, I want to kind of set the backdrop a little bit, taking a look at the current healthcare landscape, and And because healthcare is a very, very wide and very broad as an industry, and I'm going to be focusing in on a relatively narrow slice of it, which is identifying and stratifying risk of different patient populations. And one of the reasons that we do this, and this is very, very prevalent in healthcare right now, has a lot to do with the health, at least of the United States, and this is really in many Western countries. But a recent study found that 60% of Americans now live with at least one chronic condition, while 40% live with 3 or more. So a chronic condition is something like diabetes or heart disease or CPOD or some of these. It's not like you went and had a heart attack and and maybe had a valve replacement and then you're better afterwards. These are conditions that exist kind of over time. And obviously, when people have chronic condition, it can lead to a lot of additional, kind of bad health outcomes. But it's really pretty alarming when I saw this: that 60% of the population, 60% of adults now live with at least one chronic condition, and 40% live with 3 or more. This population consumes hundreds of billions of dollars in healthcare spending every year. And I think the other thing the RAND study goes on to say, it's only going to get more urgent as the overall age of the population increases, especially with the baby boomers coming through. So I think that's it's a pretty alarming statistic. The other thing that it's probably worth saying before we move on is that when we talk about chronic conditions, say like diabetes, a lot of these are preventable or at least manageable. And so that's really the whole idea of a lot of the analytics that they're doing in healthcare right now, which is how can we identify people who are maybe at risk of getting sick, but haven't gotten sick yet, and try to intervene and try to, with education or maybe medication or whatever it is, before they get very sick. And so it falls under this heading of what we call population health. The challenge for providers is that it really requires them to have different data and to, in some extent, behave in a different way. Traditionally, the healthcare model is you'll just sometimes you'll have a patient and then the doctor or the paraprofessional is considered a provider. And they kind of just wait until you show up. And usually, if you're like me, you wait until you're really sick to show up. And so the whole idea is that let's say that I'm at risk of developing diabetes, but I don't go early enough and it doesn't get picked up. By the time I go, because I'm having symptoms, the disease may have progressed a fair amount. Where if they had known that I was at risk earlier on, they could have reached out and said, hey, why don't you come in and talk about health and exercise and some of these things, and kind of in a set of preventative services. And so, which makes perfect sense. The difficulty is that if the healthcare ecosystem is going to change more towards preventive services, then how do we identify people that are at risk and intervene early? So that's kind of the landscape. So in order to do that, the first thing we need is a data warehouse. What we're going to see here, and this is not a great slide, but usually what we'll have traditionally inside a hospital or a doctor's office or any group is, you will have data in an electronic health record. And so this is when you walk in and they will click you in, and all of the medications that you're on and all of the every time you've seen the doctor and things like that, that's all there. But in addition to that, you'll also have some of your data out in claims data, which is in the insurance company. And this is relevant because this is where a lot of the healthcare costs are actually encapsulated. And it really has to do with what the insurance company paid out. Unfortunately, the electronic health records don't have really good cost data. The hospitals are working diligently to try to improve upon that, and they're making strides every year. But when we really want to know what the true cost of service is, at least today, more often than not, we'll get claims data from what we call the payers, the health insurance companies. In addition to that, we have these care management platforms. So the whole idea, this is kind of the equivalent of a CRM system, where we have patients up there and they might have a care plan that says we want to check in every 6 months to make sure and check their blood pressure or check their blood sugar, or maybe they're supposed to be following certain regimens of diet and exercise. And so by having this outbound outreach system, like these care management systems, we can reach out to the highest risk people, kind of proactively along the way. So generally what we'll find is that you'll have, kind of every hospital, at least in large multi-specialty groups, will have their own electronic health system. Probably they won't necessarily have claims, but they'll have care management. And then the social determinants of health, I'll maybe touch on that later. But when we're trying to aggregate this data, it's really not often prudent or even possible to reach into the back end of the health, the EHR system, or the electronic health record. So what we really want to do is we want to extract the data from those operational systems and move them into a warehouse. And so this is essentially what this schematic is showing, is that we can move them directly through a file feed or this emerging standard called FHIR, which I'll touch on briefly. Once we have the data in our warehouse, then what we're going to want to do is build a whole series of kind of predictive and risk models around the data in the warehouse. And then more often than not, we'll build our dashboards and visualizations off of the warehouse, primarily because the warehouse then can have kind of a richer ecosystem of data. And then oftentimes maybe there's a couple of different electronic health record systems in the hospital ecosystem. And so all that data gets brought together at the enterprise data warehouse level. So any questions on this so far? Great. So this is a schematic of what a typical healthcare data model looks like. And if we were to look at, say, a CRM system, and you were to look at Salesforce versus maybe the Microsoft product, they'd have similar structures, and the same with healthcare. So essentially, everything revolves around patients and providers at its core. And remember, the providers are the doctors and the paraprofessionals providing service. And then providers belong to organizations. So you can imagine, if you have a primary care physician, and they might be associated with Cross Hospital or maybe St. Joe's. And so, the Cross Hospital as an organization will have many providers, all with different specialties. And then oftentimes providers will work as part of maybe a specialty group themselves, but then have admitting privileges to one or more hospitals. And so these tend to be, reasonably fluid linkages. And so when we're talking about building a kind of a relational model or a third normal form data model, this is essentially how we would structure things over on kind of between patients and providers in the organizations. Now, the heart of any electronic record and any electronic medical record or a data warehouse is what we call an encounter. And the encounter really is an event that is most often you go to see your doctor on a certain date with a certain problem and to report something. And the thing is that, you oftentimes people will see their doctor more than one time a year. So they will have an encounter record for every single time that they see their doctor. So in a simplest form, you might have 2 or 3 encounter records if you go to see your primary care physician, a few times a year. However, if you were in the hospital where you're seeing many different specialists, maybe you're in for surgery and then you'll have the surgeon and you'll have, the anesthesiologist, and you'll have other specialists that come in, you'll have a lot of encounter records. And what it is just, again, it's an individual, it's a record in the database for every single time some service was provided or there was some exchange of information. Now, once we have an encounter, and we'll take the traditional ones where you as a patient go in to see your doctor in primary care, the first thing that the doctor is going to do is, as they're talking to you, they're going to fill out anything on what we call the conditions. And so I'm here because I have a sore throat, or I'm here because I have chest pains. And so the conditions are actually standardized diagnosis codes that the doctors or the nurse practitioners, whoever is seeing you, will fill in. And all of those codes are kind of standardized that are established by the government. And so that's a very important thing. If we want to find out all the people who say are diabetic, we know there's a standard code for diabetes, and so we can go out and we can look to see, find me all the people that have a condition or a diagnosis of diabetes. We'll always see kind of an observation table. They may be named a little bit differently, but this is generally when you go in and as part of an encounter, they might take your blood pressure and they'll record that. Maybe they're going to do some lab work and they'll, which will measure your blood sugar and your LDL and your HDL. All of that is is captured, and then it's put into another table inside the database in what we call, in this case, observations. Obviously, medications are key. So whatever medications you're on, and again, medications tend to be tied back to an encounter, although they have a start and a stop date. But the whole idea there is that you are given a medication because it's in response to an encounter where a diagnosis was made. And so that's how that that even though they're going to be in a separate table in your EHR and in your warehouse, that's how that join is brought together. And then obviously any procedures, immunizations, and care plans are kind of less important, probably less relevant. We'll talk about them right now. But procedures, if you go in and have your arm set because it was broken, or you go in for heart surgery or whatever it is, there's a whole series of procedure codes, a whole series of medications, and all around the condition maybe somebody has a diagnosis of heart disease. So I think this is kind of a pretty standard healthcare data model, and you'll see these kinds of data files that contain this kind of information in almost every electronic health record or most healthcare data warehouses. They might be named a little bit differently. Obviously, we'll have more tables, but this is a pretty standard kind of reference architecture. Any questions on this so far? Great, okay. So one of the things that I had mentioned before is how do we get data out of these transaction systems, the operational systems, into the warehouse? So historically, what we can do is we can extract data from the actual electronic health record itself, and we can output that to some sort of intermediate file format, or we can have our ETL tools extract, transform, and reload, read in directly, although that's probably not very safe from scalability and from security. So there'll usually be some sort of interchange, a file exchange. And while that still happens, there's a submerging standard called FHIR, which stands for Fast Healthcare Interoperability Resources. And what FHIR does is essentially there's a series of servers, a computer server, kind of a web server, a secure web server. But then it sits in front of an electronic health record, and it then will present to any client or any basically it can be a ETL coming in, it can be a web service, it can be really anything that wants information on a patient or an encounter or an observation or medication, allergies, the vitals, any orders and things like that. And so what it does essentially is it sits in front of the HR system to kind of abstract that away. But the beauty of it is that can be very secure. So we can put these FHIR servers inside like a DMZ so that the EHR system is hidden behind another set of firewalls. And then the FHIR server is also hidden, but it creates a secure level of security. But it also, since the FHIR standards are established by this organization HL7, which is a nonprofit sponsored by the industry, and everybody adopts to it, we can have a FHIR server that'll sit against many different electronic health record systems. So you might have one going against the Epic system, which is one of the ones that big hospitals use, or the Cerner system, or any of the other electronic health records. But you can create a single interface point for any, maybe your web applications or your EHR or your ETL systems or anything. But so FHIR is really an emerging standard that anybody that's interested in healthcare and healthcare interoperability should be aware of, because it's making life just much simpler, for the healthcare data analysts and data professionals. So if you're curious about that, this is something, and you're especially interested in this industry, this is something that you should be aware of. And then finally, one last kind of best practice. And so remember, we built our warehouse here, probably better. And so now what we want to do is that we want to be able to create dashboards, or we want to be able to feed our risk models for our machine learning or whatever we want to do. There might be a tendency to have all of these data sources connect directly to the data warehouse. Maybe it's a SQL Server database or something. I would caution people against that. Instead, what I would recommend you do is you build a series of database views. And for people that are not familiar with database views, think of them as a logical table. But what they're doing behind the scenes is they're actually doing these joins. And inside Microsoft SQL Server, MySQL, and Oracle will have the ability to create these logical tables, which are database views. This does a couple things for us. Number one is it makes sure that people that are subscribing to that want to see the data only see what they're allowed to see. Because you imagine if you download, let's say you're building a visualization, if you download your entire patient file and then have it sitting on some disk someplace to be able to populate a dashboard, that's a huge risk. However, if your dashboard solution, maybe it's Power BI or maybe it's Tableau or ClickView or anything, connects into a database view, the dashboard itself isn't really storing any data. It's simply just sourcing data and displaying it. So we create a much more kind of secure environment so that we don't have protected health information floating around. The second thing is that it provides benefit from it just is for performance standpoint, because if you have to download kind of 50,000 patients with millions of transactions and so you can load a Tableau dashboard, if you're doing all of that in Tableau, it's going to take a long time. But SQL database engines are very good at doing these joins and essentially kind of serving up these logical tables very quickly. And so as a result, it's just a much better. And then of course you can make yourself front end agnostic. So if you build these views, you can not only have Tableau connected, you can have your web application. You can have any other system really come in to and see this. So it's just a best practice that we follow. So let me stop there for a second. Any questions so far?
So it looks like we have a question in the chat from Angela. What kind of encryption is used with FHIR, and does it encrypt at rest and in transit?
So excellent question. The FHIR servers themselves, depending on how you configure them, but all of the encryption in transit is always going to use whatever the standard internet protocols will be for that. So it's got to be kind of 128-bit or whatever. I can't remember the name of it right off the top of my head. So that's the data that's in transit will always be secured the same way as any secure web traffic will be. The data at rest is tricky. So if you set up your FHIR server, let me just go back out here. Can you guys see this?
No, you're not sharing your screen.
Oh, I'm sorry, I stopped sharing. Let me go and. Here we are. So can you see it now?
Yes.
So if we set up our FHIR server properly, then the FHIR server is doing nothing more than reaching through and pulling data out of the EHR database directly. And in that particular case, there is no data that's sitting at rest here on the FHIR server. And as a result of that, we don't have to worry about this secondary repository of securing the data at rest. However, there are ways you can set up the FHIR server where the data is imported, and it probably improves some performance. But if you do that, then you've got to make sure that whatever server this is running on, so it's running on some sort of, kind of just an application server, and the data is probably going to be stored in a JSON file format, sitting out on a volume that's mounted someplace. You've got to make sure that that volume is actually encrypted. And so if you're doing it locally, then there's whatever the operating system would have encryption techniques. If you do it in the cloud, then you would use whatever those encryption techniques. But it's something that you really have to remember, because if the data is sitting out there that's at rest, and you don't think through, oh my goodness, that's a risk, then that's a huge kind of vulnerability. And then if you get audited, you'll get in a lot of trouble for that. So that's an excellent question, and it's something that's paramount especially as we start adding more layers in to kind of all of our infrastructure here. I think the other thing, kind of building out that kind of goes without saying, but if we're going to build a warehouse, that data also needs to be encrypted at rest. And so that can be done either by encrypting the disk, or if you use some modern, like SQL Server or even in Azure, SQL Server on-premise will allow you to basically encrypt just the data in the data file itself. So, but that's super important. Did that answer your question? All right, great. So the next thing, let's just talk a little bit about, kind of pivoting over in the analytics, talking about risk scoring and building some predictive models. So you might say, well, how do we identify and risk score someone that, is say a diabetic or at risk of developing diabetes? And so what we're really trying to do, it's just a fun little graphic here, but we have, if you're a provider, you have this patient population, and you're really trying to identify people that are in your population that are at some sort of risk, and that maybe they have diabetes already, or chronic hypertension, or maybe they're getting it. And so the idea is if we can find these people before they come in to see their providers, and then proactively reach out to them, then presumably, ideally we can help keep people well. So the government helps us here too in the industry standards. So what they've come up with is a series of standard measures, and they've come up with these bandings or these kind of benchmarks. So for instance, one of the key measures for diabetes is a measure called HbA1c, which is it's a measure of blood sugar concentration in sugars in your blood. So if you have your blood drawn and you have an HbA1c value of less than 7, then that's considered controlled. And that can be controlled because it just is naturally, or it can be controlled because you're on medication. But in either case, it's fine. It's kind of like having blood pressure of, kind of 80/120. It's kind of in control. I don't know what the new standards are. But if your HbA1c goes from 7.1 8.9, that you're kind of considered at medium risk, or they call at risk. But if it's greater than 9.0, your risk is high. So one of the ways that we can begin to identify patients in our population that are either medium or high risk is by simply looking at their latest blood panels. And we set up a filter and show me all the people who have an HbA1c at their last blood draw of greater than 9.0, and boom, all of a sudden you've got a high risk. You've identified one of the factors that can cause high risk. Now, that's not the only factor. Also, what we're looking at is, whether have they been screened or not. It might be that I haven't had a HbA1c screening in a long time, so that potentially puts me at risk because maybe I'm over 40 and meet the criteria, so I have to go out and get screened or have my blood drawn. Same thing with lipids, and so they're, whether you have a panel or not. But assuming that you have both of this blood work, then they're looking at your LDL, and if it's less than 70, it's controlled. If it's less than 100, usually 70 between 100, it's at risk, and greater than 100 is high risk. And this is just, there's literally hundreds of these for different chronic diseases and different measurements. But the main message here is that you don't have to figure out on your own what the risk factor is necessarily. A lot of this is given to you, and so we just build this logic into our analytic systems, kind of as a first pass. So that's kind of, again, just one way that we can kind of identify people that have risks. Now, if we want to get a little more sophisticated, what we can do is we can build some kind of predictive analytic pipelines that will take data and basically do some cleaning, and oftentimes we have to do some merging, but then we can build some predictive models. These are usually classification models that will look at a much wider set of data and come up with an overall risk score for a patient. So someone that has, an HbA1c of say 7.5 is probably, it has a risk factor, but it's probably less than someone that has HbA1c of maybe 7.5, but an LDL of, whatever that is, and high blood pressure. And so the whole idea is that these risk factors can compound. And so how can we come up with an overall composite score of an overall probability or a risk score? And this is where the predictive models and the classification models can actually help us. So I'm going to show you a working example of this. This is using a product called Ultrix. I don't know if anybody's familiar with this or not. It's actually a really cool tool. What we're going to do here is we're going to source data from two sources. We have a patient file. Now, right now, this is just in this particular example, it's probably reading off a CSV file someplace, but we could just as easily connect into the patient table in our data warehouse, which is what we would do most often. And then looks like it's taking a minute to load. Let me talk through. And so what we see over here is some information on the patients. Now, this doesn't, if you look at the data here, this is actually probably data from their location, but their smoking status and the Lipitor. So this is probably a database view that was created that combines a bunch of information from both their diagnosis, maybe from their lab work, and maybe from, in some demographic information. And so it's all brought together into one kind of flat record for each patient. We also have a second file here that basically is the diagnosis. And so this is coming from, and what we have here is the same patient, or patient ID, the year that was reported, the blood panel, some information on what the actual results were, and the reference ranges. And so this is actually, we're just using, just as an example here, we're just using two different inputs. Most often, if we're going to build one of these machine learning models, we would probably build it, kind of maybe have a few different data inputs to create our join. What we do here is we're going to go through and we're going to, kind of in this particular case, we're going to do some data transformations just to split some data out into different fields, and we're going to rename some columns. Down here, we're going to do a group by so that we can, because what's going to happen over here is a given person can have multiple different diagnoses, and so then we have a one-to-many problem. So we'll do a grouping, and down here we'll group by patient ID, and then we're looking for is abnormal values. We bring these together, we do some more cleaning where we'll just get rid of the zero values. And this is a really traditional data science pipeline. So if you took kind of one of our classes, or like Amanda used to teach, we teach these pipelines. But when we actually want to go in to build our classification model, we need to split the data stream into two sets. One is our training set and one is our test set. And so what we're doing here is we're just actually splitting. Usually when you do a split, it's going to be probably a 70-30, where we're going to use 70% of the data coming in for our training set and 30% for our test set. But there's nothing magical about that. Sometimes people do 80-20. So it's really kind of up to us as data scientists to figure that out. And then what I'm going to do in this particular case, I'm going to bring in a logistic regression model. And so logistic regression is just one of many classification models. If you look up here on this particular tool, we could have brought in a random forest. We could have brought in a naive Bayes. We could have brought in an artificial neural network. Or a boosted tree model. So there's a lot of different models, and typically what we'll do is we'll run many models side by side so we can compare and see which ones work. And then essentially after that, next step in our pipeline is really just to basically validate the model. And then what we're gonna do here is the model will always output a probability, 60% risk of and so what we want to do here essentially is change that. So if the risk score is kind of equal, greater than or equal to 70, then we're going to list them as high. So that's a kind of typical data science pipeline. So let's just see if this thing will run. And so one of the things about that's kind of cool about Ultrix is that it's a desktop tool. So it's kind of, you can watch it as it's running. Right now it's kind of churning through this the patient diagnosis table. And you can see the joins up here, and now it's creating its set. And then it basically ran in that amount of time. Let's see, didn't really tell us. There's, we can, oftentimes if it's going to throw any errors, it'll tell us. But the first thing we can do is, okay, so it got all the way through. we can essentially look at our model, and we can see we had a classification accuracy of 0.69, almost 0.7. So what that means is that it guessed right 70% of the time. So that's not bad. You know, we sometimes you'd want to see more, but anyway, a lot of things we would do to tune the model, and we can improve upon that. But at least that tells us that, you know, our model is guessing accurately 70% of the time, which is better than a random guess at 50-50. So it's probably worthwhile. And then it's going to go through and create its columns. But then ultimately what we're going to see down here is the output of that is a table that's a merge of those two. So we patient ID, gender, year of birth, smoking status, all of this information. But then ultimately we see over here is a segmentation, whether that patient is high risk, medium risk, or low risk. Now, we put a filter on here only to see high risk patients because this is probably the population we want to go after. So what we've done essentially is created a list of patients that are at risk, that are high risk patients based on a much more complex set of conditions other than just simply looking at the one factor, like looking at the LDL or looking at the HbA1c. This considered many factors. And so this is where kind of classification and predictive modeling in healthcare is really very helpful, because there's a lot of data. It's really complicated. And so if we can kind of build it into these machine learning models, things are much better. So just one more slide here. Actually, they're just a couple of dashboards. I just want to show you. Let me find them here. So then finally, the whole idea is we've been through this pipeline, and the last thing we want to do then is create some visualizations. This is an example of a visualization that could be used by someone in the doctor's office who is trying to identify at-risk patients, or maybe a care manager who's on the phone trying to reach out to people saying, hey, we haven't seen you in a while. But what they'll have is a dashboard like this, and what they'll have is essentially on the dashboard, we'll have individual, you know, kind of patient information down here. This is a patient, you know, individual patients. But we can say, let's see all my high-risk patients. So you can just click on something like this, and instantly it's going to show us only the high-risk patients. And let's look at all the high-risk patients for CPOD. You can set a filter over there, and it'll kind of drill in specifically. And so we can use these dashboards to kind of slice and dice the data to see, you know, what facility they're being seen at. Maybe we have a number of different offices, or maybe they, you know, belong to their one physician more than another or something. So the dashboards are really used for interrogation and for asking questions of the data. And obviously, in a perfect world, we've brought the data into our house. We've enhanced it by building some machine learning models and classifications, and we pushed those risk scores back into the data warehouse. And now our dashboards can see data that's actually been sourced, but also has some predictive modeling derived values in there also. So this is a pretty typical dashboard that we might see. And so this is one way to look at it. The other way that's kind of emerging is geospatially. And so in this particular case, what we would have is a dashboard. This is data from New York City. And we might want to do is look at, you know, kind of demographics. And so we can see, you know, maybe where there's, you know, kind of poverty or education. Let's start with the health outcomes first. So show me the place where we have, you know, high degrees of maternal morbidity. And we can see the zip codes that are there, or a lot of stroke hospitalizations. And so we can see the data there. Or maybe we want to see poorly controlled diabetes. And so one way that we're managing these populations is by looking at individual patients and identifying risk scores. Another way that we're doing is we're looking for areas where, because many of the people, especially with some of these, you know, in some of the underserved populations, they don't even necessarily have doctors. And so the second thing that what public health people will do is they'll go out and they'll identify these geographic areas that have high risk, and then they'll go out in the community and do outreach. And so they're using these geospatial kinds of visualizations to help them with that. So that's kind of all I got. I wanted to kind of get through it and kind of give everybody kind of a sense of it, and then also see if there's any questions.
We have another question in the chat. How do you collect the HbA1c data?
So the HbA1c data comes from a lab feed. So when you go, let's say I was just at my primary care doc, kind of a week or so ago for my annual checkup, and they drew blood. So that blood is then sent out to a lab. And then that lab, there's a number of big labs around, and that lab then takes your blood and then does it breaks it all down and will look for the things that they're looking for. The lab will then send an electronic record of all of your blood values back to the hospital in a secure message form. And all of the electronic health records and or data warehouses have the ability to ingest those lab files directly. And so it'll be applied back into your EHR system. So all of that is very automated and very standardized. So you'll get your blood drawn, it goes out to a lab. Most often the labs are third party, although some of the big hospitals have labs themselves. And then the analysis computers themselves actually will then take those values and create an electronic record. Electronic record is then pushed out to wherever that system is, and it will be ingested automatically. That along with all the other values that they were looking for in your blood draw. Does that answer the question?
So I have a question.
Sure.
I was wondering, you mentioned a few times a couple different databases that might be used for electronic health records or the underlying infrastructure of these data systems. Do you have a preferred platform for healthcare data?
No, I think what you find is that everything's driven by, so there's 3 or 4 major vendors that are out there. So for those of you, if you're familiar with CRMs, it's always Salesforce, but kind of fighting it out against kind of Microsoft, whatever they call it these days, and maybe an open source and a bunch of small startups. And so all of the vendors are out there and they're competing for customers. The healthcare data space is the same way. It's just they're different vendors. And so the large dominant vendor is a company called Epic. And they're very big and they're very complicated, but they also really work at scale. So they tend to be the ones that are in the big hospitals. If you're a small little practice, or maybe you're some specialist group, you might choose a different system called MedEnt is another one, or Cerner is another one. So there's players that are out there already, and that's always kind of selected by the practice. But generally what happens is that those practices are transaction systems, but most healthcare providers will just extract the data and bring it into a data warehouse at that point. I would say, in my experience, the vast majority of those data warehouses are running on Microsoft SQL Server because it's fast, it's relatively easy to use, it's secure. And so what you probably, as a data analyst, what you'd probably be interacting with is a database platform, but more likely than not, it'll be Microsoft SQL Server. Seems to be the one that's out there. And so you kind of go with, it's not as cheap as maybe an open source MySQL, but it also is, it's also, kind of just the industry. It's not the industry standard, but it's the one that people vote on, that use the most.
So we have another question. Is Alteryx tool good to use only for healthcare, or can it be used for other industries?
Oh, no, it can be used for every industry. As a matter of fact, I would say Alteryx, it's a great tool. And I'm not here promoting it. I happen to use it in my consulting practice, and we get a free version as university people for our students. And so, but yes, it's used an awful lot in a variety of industries. Their real sweet spot tends to be in kind of consumer and geospatial, kind of applications. But it's a Swiss Army knife. It's really great. So you can use it with any data source. You get hundreds of different data sources and different applications, and it's a really great tool. I don't actually think it's used that much in healthcare because it tends to be for, kind of citizen data scientists or people that are doing things like this. But if you're going to basically build an industrial strength ETL tool, you'd probably use Microsoft's the SQL Server integration services or Informatica or some of the kind of more industrial strength ETL tools.
What are your thoughts on healthcare data in the cloud?
So that's that's both a technical and an emotional issue. I'd say from a technology standpoint, the cloud is, as if it's done properly, you have lots of HIPAA compliant cloud service providers. So if you want to store your healthcare data in the cloud, you can store it on Amazon, you can store it on Microsoft, and Google, and all of those providers and others will have a HIPAA compliant cloud solution offering. And what that really means is that they will give you kind of an isolated component that will allow you to encrypt your data kind of at rest, and then also kind of in flight. They'll also give you, it's sophisticated enough where you can set up the securities and permissions that you need. But the thing about healthcare data and being HIPAA compliant, HIPAA is the Healthcare Portability Act, is that it's more than just storing it in a HIPAA compliant computer system. You have to follow processes and procedures that you kind of, what makes it HIPAA compliant is that you're treating the data properly. And so during a HIPAA audit, they're going to want to see all those things, but they're also going to want to see what your management procedures are and how you do audit logs and things like that. So while you can store the data up there and it'll be kind of HIPAA compliant plumbing, it doesn't make it a HIPAA compliant system unless you put all the management processes around it. But if you do that, it's many of my clients have been putting their data up in the cloud, especially for warehouses, just because it's faster and cheaper. And as long as it's just as secure, why not? But it comes with a lot of caveats, so it's just kind of be careful. That's my I guess my whatever the right word is, for kind of take care.
Are there sites online where people can access and download example healthcare?
They are few and far between, because you can find them. The first place you might want to go and look is a place called Kaggle. For those of you that might be kind of familiar, the problem with the data sets that you find when you download is that they tend to already be processed. And so what I just showed you is you have a file for patients and a file for observations and a file down here for labs. By the time you download the data from Kaggle and these other places, it's already been transformed into one big long record. There is one place I'll show you that I get all my data from that's actually SYNTH. It's called Cynthia. So this is a nonprofit from Mitri Corporation, and essentially what it is, it's a synthetic data generator. And so what you can do is it runs a series of small little Python scripts, and it'll generate synthetic patient data that looks very realistic. But the beauty of it is that it will generate that data in a format in its kind of composite form. So it'll output a patient table, and then a table on labs and a table on medications and everything. So you actually get a pretty realistic view of what that kind of healthcare data looks like at its raw level. You can then ingest that. You can build ETL to bring it into warehouses. You can create your own populations. And so if you look up Cynthia, they've got a number of pre-built data sets that you can just download. Or if you are interested in and can do some really minor duty coding, and it's not even coding, it's just basically setting up, kind of running. I think it runs on JavaScript, or I can't remember exactly. But you just set it up, follow the instructions. You can generate your own. So if you're just interested in playing around, then you can probably find some out on kind of in the normal repositories. But if you really want to get kind of down inside and really begin to familiarize yourself with what healthcare data looks like at its most elemental level, then I would suggest you go to Cynthia and start looking around, where to download data sets. I'm happy to, send people where you can actually get pre-built sets and things like that if there's any interest.
So that was going to be my question. Would these sources give experience with the coding specifically? This is like all new to me, but I've been kind of on the job search and I've seen some specific employers that want people to have experience with medical codes and working with EMRs. So I don't know if this would be a good way to kind of dabble in that without like having direct work experience, do you think?
Yeah, so yes, I think it is. I think two things. The first thing is to kind of get familiar with all the different medical codes, because there's a bunch of them, and they're all used for kind of different, kind of different facets, and sometimes they overlap. But if you familiarize yourself with all the different medical coding standards that are out there, then that's kind of not even step one, but that's part of the puzzle. The other part of the puzzle then is just go to Cynthia, download a series of CSV files, and what they look like here. Let me show you. I can excuse all my junk out here right now. iSchool did. There's just a series of CSV files. So if we want to look at the patient file, it's going to give you a CSV, and you can see kind of the actual patient file itself. And then if you want to see maybe a provider's file, it gives you this. But the beauty is when the data is generated, it already has the foreign key relationships. And so you can basically take this data, and then you can just kind of play around with an Excel, or you could do something like bring it into SQL Server Management Studio, just import it, and then kind of build the joins that way. But this data is really very realistic. When you look at, let's just say, the observation data, these are big files here. So, but they're real lab values. They're lab values that have been generated that would be realistic for someone with type 2 diabetes. And they're the medications for someone that was with type 2 diabetes. So the data is actually even though it's fake, it's very accurate and very realistic. And so it's a really, really good way to get yourself oriented with what healthcare data looks like. So that would be, a really good place to start. And I think, I would recommend you do this before you go talk to the healthcare people, because if you walk in there saying, well, I've seen some things, but if there's a series of nomenclature that the healthcare providers want to see. So they want you first and foremost not to talk about customers, to talk about patients. But they also want you to talk about, kind of understanding what this data model looks like and encounters, and then understanding what a medication table look like and what are the standards around that. So I think if you can get yourself familiar with the data and the naming, and then go and look at some of these CSVs that are created by Cynthia, you actually can get yourself pretty well prepared so that when you walk in, you're speaking their language. And then that's the main gate. If you can't speak their language, then you don't get a look. If you can speak their language, then you kind of get let inside the tent. And then once you're in, you become kind of badged. And the beauty of it is that for those people that don't do that, it's hard to get into the healthcare industry, because you have to understand this language and you have to understand the data. But once you get in, there's a huge amount of demand and there's a little bit of supply, because not everybody really understands the language. So then it really kind of makes your opportunities greater. So that would be my recommendation, is really to kind of get familiar with the data. I think the Cynthia data sets are a very good place to start. You don't have to download your own. You don't have to generate your own. You can just download a couple that are out there someplace. Kind of get familiar with the different standards with HL7 and a lot of the different codes that are out there. And I think, probably with a relatively small amount of concerted study, you could actually get yourself to be very fluent in this space.
Thank you. That's really helpful.
Good.
Final questions for Steve. Okay, well,
Oh, we had one.
What is the difference between healthcare and digital health?
Well, I think, digital health is kind of in one sense, a buzzword. But in a very real sense, it's basically just the digitization of the healthcare data. 10 years ago, if you walked into a doctor's office, there was a really good chance that all of the you would have seen these big walls of files that are all color coded, because all of your healthcare data would have been written down. And probably about maybe 10 years ago or less, the government said this is ridiculous, and so they set up these programs, what they called meaningful use, to incent providers to move off of paper charts into electronic health records. And first they paid them to do it, but then after they hit a threshold, they started penalizing them if they didn't do it. They kind of push everybody along. So in a very broad sense, digital health has been the digitization. So now when you walk into almost any doctor's office, your doctor will be working behind a computer because they're working an electronic medical record. But it also refers to a lot of more specialized things like, you have your Fitbit and you want to upload the data there, or maybe you have a scale and you want to kind of keep track of that. So it's really kind of a catch-all term, but mainly it's your health data that's been digitized so that it's electronic. And once it's electronic, there's a lot more things we can do with it.
Well, thank you so much, Steve, for joining us tonight. This has been a real delight. Thank you, everyone else, for joining us. We a couple announcements. We do have a meeting tomorrow night at 7 o'clock. If you are interested in joining our projects arc, we are getting together, and tomorrow we're going to talk about SMART goals and how to put together a data project in a way that can be achievable. We have a talk coming up in a couple of weeks, data in technology entrepreneurship. We're going to have Jennifer Tran come and speak about her cryptocurrency startup and talk about the data that she uses in her startup. Yeah, keep an eye out for any, we do send out some job opportunities in our meetup chat, so keep an eye out for any emails if you're interested in the job market, or feel free to reach out to Ashley or I if you have any questions. We will both put our emails in the chat. Thank you, everyone. Have a great night.
All right, so long, everybody. Bye-bye.
Thank you.
You're welcome.